Okay, we're going to look at synthetic divisions this sessions. So when you're using synthetic division, you don't use the variable. It will be just a constant. So if you're looking at x squared, you have a constant of 1. X constant is 10, and you have 21. So we're going to only use those numbers. Write it down. So it will be 1, 10, 21 will be getting divided by, you have x minus 3. So when you have x minus 3, you're going to divide with negative 3. Always the first number bring straight down. You're going to have 1. And these two numbers, negative 3 and 1, is the one that you're going to multiply and write it under 10. So you get negative 3. And these two lines, which is 10 and negative 3, you're going to add them. You get 7. You're repeating yourself again as negative 3 times 7. Write it under 21. That will be negative 21. And again, adding 21 with negative 21, you get 0. What does that mean? This means when you're dividing x squared plus 10x plus 21 divided by x plus 3, you're going to get 1x plus 7 with remainder of 0. Okay, let's look at the second problem. X cubed plus 4x squared minus 5x plus 5 dividing by x minus 3. This time we're going to do synthetic division also. So again, synthetic division, you only use the coefficients, numbers, instead of variable. So from the cube, you have 1. From the square, you have 4. From the linear, you have negative 5 and constant 5. Dividing this by x minus 3. So you're dividing with positive 3 this time. You again bring down the first number straight down because you need number to multiply. And you have 1 times 3. Well, let's bring down 1 first. And 1 times 3 is 3. When adding 4 and 3, you get 7. 3 times 7 is 21. Added into negative 5, you get 16. And 16 times 3 is 48. And add these two numbers, you get 53. So your remainder is going to be 53. So you end up getting, you started with cube, right? You started with cube. You're dividing with linear. So 3, you're subtracting 1 or dividing by the linear. You're going to get 2 left over. So you're going to end up getting x squared. So 1x squared plus 7x plus 16 with your remainder of 53 over x minus 3. Will be the solution of that divisions right there. Let's look at C. We have another problem that we need to do divisions. Again, we're going to use the synthetic division on this problem. Synthetic division is same as the long divisions, where you need to write it in a descending order. And if you have any missing term, you're going to use 0 for the placeholder. So the highest exponent on this polynomial is cube, right? Cube is the highest, then square. You have linear is missing, so 3, 2, 1 is missing. So you're going to use the 0 for the linear, and then you have negative 5 for constant. So you will start with 2 from the cube and negative 10 for the square, and linear will be 0. And constant is negative 5. Dividing this with x minus 4, which is going to be positive 4. First number always bring down, straight down. And these two numbers multiply 4 times 2 is 8. Added into negative 10 is negative 2. Negative 2 times 4 is negative 8, which will give you negative 8. 4 times negative 8 is negative 32. Add those two numbers, you get negative 37. So again, this is your remainder, and your solution is, you started with cube, so now it becomes square. X squared minus 2x minus 8 plus your remainder negative 37 over x minus 4. That will be the solution of your third problem. Example 3 is asked, given f of x, use the remainder theorems to evaluate f of 2 for part A. So what does that mean? We did the evaluation before. When we did the evaluations, f of 2 is asking you to replace all the x on the f of x. So here, your f of x is x to the 4th plus 6x cubed minus 12x squared minus 30x plus 35. So you're replacing all the x with 2. You get 2 to the 4th exponent plus 6 times 2 cubed minus 12 times 2 squared minus 30 times 2 plus 35. We did this before, right? This is how we evaluated, where you need to do all this algebra. 2 to the 4th exponent is 16. 6 times, that's 8, is 48. And minus 12 times 4 is 48. And then minus 30 times 2, 60, plus 35. And when you add all the positive, you end up getting 51. And don't forget 48, positive 48, negative 48 cancel out. And then the negative is 60. So you end up getting negative 9, right? Remember doing that for the evaluations. Here we're going to see if we can use the remainder theorems. Remainder theorem is using synthetic divisions. So in order to use synthetic division in f of x, let's copy down all the coefficients. So x to the 4th, your coefficient is 1. X to the 3rd, your coefficient is 6. Square, coefficient is negative 12. Linear, your coefficient is negative 30. And then you have positive 35. You're dividing this with 2. If it's the number itself is given, that's the number you're dividing. Then you bring 1 down. 1 times 2 is 2. Add this will be 8. 2 times 8 is 16. Add into negative 12, you get positive 4. 4 times 2 is 8. Add it into negative 30, you get negative 22. And you multiply 2, you get negative 44. And when you add these two numbers, you get negative 9. So this number is same as that number. So in order to evaluate, you can replace x with the value, but you can also use the synthetic divisions like I did it in the second part, right? So then if I wanted to try f of negative 7, I think once you get used to doing synthetic division is easier to evaluate. So if I use synthetic divisions, copy down all the leading coefficients. Well, coefficients, right? Negative 30 and 35. And you're dividing this with this time negative 7. And bring down 1, so you have something to multiply. 1 times negative 7, add, will become negative 1 times negative 7 is positive 7. Add those two numbers is negative 5. Negative 5 times negative 7 is positive 35, which gives you 5 times negative 7 is negative 35. Here you have leading coefficient 0. Remainder 0. Whenever you end up getting remainder 0, this means your value is solutions, or value is the factor of your polynomial. So negative 7 can be a solution, but also x plus 7 can be the factor of your f of x. Or negative 7 is the solutions. One of the solutions you have for this polynomial functions of f of x is negative 7, or x plus 7 as the factor